Hello everyone, here is the problem on screw jack. A screw jack is to lift a load of 80 kilonewtons through a height of 400 mm. The elastic strength of the screw material in tension and compression is 200 megapascals and the shear is 120 megapascals. The material for nut is bronze, for which the elastic limit may be taken as 100 megapascals in tension and 90 megapascals in compression and 80 megapascals in shear. The bearing pressure between the nut and the screw is not to exceed 18 Newton per mm square. Design the screw jack. So here is the question that we got. Okay, so the given data is mainly indicated to screw jack with the load 80 kilonewtons, height through a height, that is the lift height is 400 mm and bearing pressure is 18 Newton per mm square. The rest of the data is related to allowable values. Okay, so let me write the given data. Okay, so the given data is given data is load is 80 into 10 to the power of 3 newtons and height and the lift height he has given as 400 mm. Bearing pressure he has given as 18 Newton per mm square. Okay, so this is the thing he has given, and the rest will be allowable values, that is sigma c or elastic limit of the material, screw material in tension and compression is 200 megapascals. That is tension and compression elastic limit will be 200 megapascals and in shear will be 120 megapascals he has given, and megapascals, and for bronze the material for nut is bronze, for which the elastic limit is taken as 100 megapascals. 100 megapascals. Okay, and rest elastic limit may be taken as 100 megapascals in tension, 90 megapascals in compression, okay, and 80 megapascals in shear. Okay, these are the elastic limits. Okay, 90 megapascals for compression and shear will be 80 megapascals. Okay, so this is the given data that we are having. So from this we have to start the problem. So we have to start the problem with the pitch circle diameter using bearing pressure formula. Okay, so that is D is equal to root over 2W by pi into psi into PB. So this is the formula that we are having in data. So see here, so this is the formula that we are having. The pitch circle diameter of nut or screw rod will be 2W by pi into psi into PB. So the psi value for solid nut will be lies between that is H by D value will lies between 1.2 to 2.5. Okay, you can take any of the value. So I am taking psi value is equal to 2. Okay, okay, that is an assumed one. Okay, assume. Okay, so the value that we are getting is root over 2 into W, 80 into 10 to the power of 3 by pi into 2 into bearing pressure value 18. Okay, so we have got an answer of 37.6. okay, around 38 mm. Okay, so this is the value of pitch circle diameter. So based on the pitch circle diameter we need to find out the other values of major diameter, minor diameter and of a screw and nut. Okay, that can be found out from the tabular column. So we can select any of the series, that like normal series, core series, whatever the series may be. So here is the value that we have got, that is 38. So we will be in a thought of selecting the next standard dimensions. Okay, so if we select the next standard dimensions, we should get, if you outside diameter plus inside diameter by 2, if you do that, you do that problem, or you do that calculation, means you should get the pitch circle diameter. So we are not getting 40 plus 28 by doing 40 plus 28 by 2. We are not getting the pitch circle diameter that we have got, that is 40 plus 28 by 2 will gives you 34 only. Okay, so later we will go on like that up to, so 44 plus 32. Okay, 44 plus 32 by 2, so 38. So that is the pitch circle diameter that we have got. Okay, so that's why we are selecting this value. 44 is major diameter of bolt, 44.5 major diameter of nut, 32 will be the minor diameter of nut as well as bolt. Okay, 12 will be the pitch and thickness will be the thickness value, and as we have selected this, the area will be 804. Okay, so this is the values. Sorry guys. Okay, so this will be the thing that we are going to select. Okay, now the screw diameters. So major diameter will be 44, minor diameter will be 44.5, and TC. So major diameter of screw will be 44, major diameter of nut will be 44.5 major diameters. Okay, okay, minor diameter of screw and nut will be both same. Okay, pitch value will be 12, thickness value will be 6. So this is the values that we are having. Now we have to calculate the axial compressive stress of a material. So first thing that we are going to do is we are going to design a screw. For calculating the design of a screw, we have to calculate the axial compressive stress of a material, of a screw. That is, axial compressive stress of a screw will be sigma c is equal to 4w by pi dc square. Okay, sigma c is equal to 4w by pi dc square. Okay, so we will be getting 4 into w value is 80 into 10 to the power of 3 by pi into dc value, dc square. Okay, so we will be getting an answer of 99.47 Newton per mm square. Okay, so this is the value that I have got. So here the compressive stress value will be 200 megapascals, so which is less than the value. So our design will be in a safe hands. Next we need to calculate the torsional shear stress. So torsional shear stress in the screw, tau is equal to 16t pi dc cube. 16t pi dc cube. Okay, t is equal to w tan alpha plus 5 into d by 2. So w value will be 80 into 10 to the power of 3 tan alpha. So here the alpha value is not given, that we have to calculate. Okay, so alpha can be calculated by tan inverse lead by pi d. Okay, so tan inverse lead value is nothing but pitch by pi into pitch circle diameter, that is 38. Okay, so we will be getting the alpha value as 5.74. Okay, next we need to calculate the mu value. Mu is mu or tan phi. Okay, so I am assuming, we have to assume, I have assumed at 0.1, so we have to substitute the values in this formula and you can get the value of it. Okay, so the torque value that I have got is T is equal to 307.86 into 10 to the power of 3 Newton meter. Okay, so that is the value that I have got. Okay, just try to calculate. After that we need to calculate the torsional shear stress, that is 16 into 308 by, that is torque value will be this one only. Okay, just I have make it a round figure, pi into 32Q. Okay, so after calculation I have got an answer of 47.84 Newton per mm square. Just try to do that calculation and tell me the answers. Okay, so later if the screw jack is experiencing both torsional and axial stress, means we have to calculate the maximum shear stress as well as maximum compressive stress. Okay, so that can be maximum principal stress, that can be found out using the formulas maximum principal stress and maximum shear stress. Okay, so sigma max is equal to half of sigma c plus sigma c square plus 4 into tau square. Okay, so half of sigma c, so sigma c value is 99.47 that we have calculated by root over 99.47 square plus 4 into tau square, 47.84 square. Okay, after calculation I have got an answer of 118.74 Newton per mm square. So if any one of you got a different answer, means just try to know. Okay, just concentrate on the procedure, because answers may be little bit vary from one calci to another, maybe in points. Okay, that doesn't matters. Okay, tau max, maximum shear stress, half of root over sigma c plus 4 into tau square. So half of root over sigma c value will be 99.47 square plus 4 into 47.84 square. Okay, so we will be getting the answer as 69 Newton per mm square. So this is the value that I have got. Next we need to calculate the, so by this we have calculated the design of screw. Now we have to design the nut. So the design of nut will be started with direct shear stress of threads of screw rod. Okay, so that we have to calculate, or else you can calculate the bearing pressure if it is not given. So here the bearing pressure is already given, so or else you can calculate the N value. So N value can be calculated. So see here, so using bearing pressure of the threads or the screw or nut will be calculated. So PB is equal to W by N into pi into D into T. So this is the thing. So PB value, that is already given in the question itself, 18. W value is 18 to 10 to the power of 3 by N into pi into D value is 38 into thickness value is 6. So we have to calculate the n value. So we can get the n value. So I have got an answer of 6.2, that is around 7. So 7 will be the n value. So if the value is not found out through this, so don't worry, just we have already have the formula like n is equal to h by p. Okay, so that is that we have calculated psi is equal to h by d. Okay, so psi value is already having, so d into 38, that is the h value that we are getting. So that is nothing but your 76. Okay, so later just substitute this 76 here. Okay, so 76 by 12, so we will be getting some 6 point something. Okay, so around 7. Okay, so n is nothing but 7. Okay, so next we need to calculate the direct shear stress in the threads of the screw rod. That can be done by W by N into pi into DC into T, and later direct shear stress in the threads of the nut, W by N into pi into D naught into T. Okay, direct shear stress, that is sigma S is equal to W by N into pi into DC into T. Okay, so W is 8 into 10 to the power of 3 by N is 7 into pi into, so the DC value we are having is 32. Just to see here, so the DC value is 32 into thickness value is 6. Okay, so we will be getting an answer of 18.94 Newton per mm square. Okay, next we need to calculate the tau n, direct shear stress in the nuts. Okay, nut threads, W by N into pi into capital D naught into T. Okay, 80 into 10 to the power of 3 by 7 into pi into capital D naught value is 44.5 into thickness value. Okay, so we have got an answer of 13.62 Newton per mm square. Okay, so with this we have completed the design of screw and design of nut. Later we have to calculate the outer diameter of nut, collar, and so see here. Let me show you in the diagram. So see here, so we need to calculate the diameter of nut and diameter of the nut collar. Okay, this is the collar, this is the diameter, and we need to calculate the thickness. So diameter of the nut can be calculated by tensile strength formula. So tensile strength formula will be W is equal to pi by 4. So this you have to remember, minus D naught square by into sigma T. So sigma T value that we have got is, let me show. So tensile stress that we have got is in the nut. Okay, so elastic limit in the nut will be 100 megapascal. So we should not substitute that 100 megapascal directly, because it is the maximum value. So we have to substitute only the allowable value. That we have to do by factor of safety. So factor of safety is not given, so we have to assume the factor of safety as 2. Okay, so pi by 4, so D1 that we have to find out, minus 44.5 square into 100 by 2. Okay, so W will be 18 to 10 to the power of 3. So we can get the value of D1. Okay, just try to do the calculation and tell me the. So I have got an answer of 63.38. Okay, so this will be the outer diameter of the nut. So next we need to calculate the outer diameter of the nut collar. Okay, nut collar we have to find out. That can be found out by using the formula of crushing strength, considering the crushing strength of the collar. So W is equal to pi by 4 d2 square minus d1 square into, so the crushing strength will be sigma c by factor of safety. Okay, so that can be found out by 18 to 10 to the power of 3. So if in the question itself, if the data is given directly as allowable value, means you don't need to do as by factor of safety. Okay, remember that, don't get confused. So here the sigma c value will be 90 megapascals. Okay, pi by 4 d2 square will be, that we have to find out, by minus 63.38 square 90 by 2. Okay, so d2 value can be found out by this, that I have got is 79.74 Newton per mm square. Okay, so that sorry, d2 value, so mm. Okay, so next we need to find out the thickness. So the thickness can be found out using considering the shearing of collar. So shearing of collar can be considered here. So see here, these formulas are nothing but these formulas only. Okay, so we are considering the shearing, direct shear stress of nut, not in threads. Okay, so if we remove the concept of threads, means we can directly use this formula. Okay, so we are just removing the n value. So n value, if you remove, means if you consider as threads, means we have to consider n value. If you don't consider the threads, means you can use this shear concept. So W is equal to pi into tau n into d0 in d1. So here we will be considering the d1 only nut value. So because we are considering the nut now, that's why. Okay, so thickness is equal to, so we are having the formula as pi into d1 into tau. W by pi into d1 into tau. Okay, 18 to 10 to the power of 3 by pi into the d1 value is 63 point, or else direct 64 substitution into tau value. So the tau value here is, we have to take the allowable value. Okay, so the tau value that we are having in the question is 80 megapascals. Okay, that is given in the question itself. So 80 by 2. Okay, so we can get the value of thickness here. So I have got the thickness value as 9.94, so around 10 mm. Okay, so this is the thickness of the nut collar. Next we need to do the calculation for where is the data book? Calculation for, so now we have to calculate the as d3. So this is the value that we have to calculate, that is the diameter of the head. Okay, and pin diameter d4. So diameter of the head and pin diameter we have to calculate. So the diameter of the head can be found out by 1.75 into d0. Okay, so here the d0 value is nothing but 44, that is given, that is taken in the so 44. Okay, so directly we have to take that value. Okay, 1 point, so d3 is equal to d2, so d3 is equal to 1.75 1.75 into 44. Okay, so this we have to remember. Okay, 1.75 into d naught. Okay, so we have to substitute that value. So I have got an answer of 77 mm. Okay, so that is the diameter of the head. Okay, next d4, that is the pin diameter. So pin diameter can be found out by d naught by 2. So the d naught value is 44 by 2, so we will be getting as 22. Okay, so this is the diameter of d4. Next we need to calculate the length of the so you need to now let us find the to overcome the friction, or you need to find the length of the handle. So length of the handle can be found out, or so the next thing is M is equal to force applied into length. Okay, length of the lever. Okay, so that can be calculated. So here the force applied వచ్చేసరికి ఏంటంటే కనుక assuming that the force applied will be 300 newtons by a person intimately. So నార్మల్గా ఏంటంటే కనుక ఒక పర్సన్ వచ్చేసరికి అరౌండ్ 300 to 400 న్యూటన్స్ అప్లై చేయగలండి. ఓకే, సో లెంత్ ఆఫ్ ది లెవర్, సో దట్స్ విల్ బి అజ్యూమింగ్ యాజ్ 300. ఓకే, and the length of the lever can be calculated. Okay, so before going to that we need to calculate the total torque to which the handle is subjected. So the total torque can be found out by T is equal to, so let me keep this aside, so later we can do that. So T1 plus T2, so the T1 is already calculated, T2 we have to calculate. Okay, so the T2 can be calculated by uniform pressure condition. So the uniform pressure condition formula is 2 by 3 mu W. So 2 by 3 mu W R1 cube minus R2 cube by R1 square minus R2 square. Okay, so that is the formula we are having. 2 by 3 mu W R1 cube minus R2 cube by R1 square minus R2 square. Okay, so that is the formula we are having. 2 by 3 into 0.1, that I have assumed 80 into 10 to the power of 3. So R1 cube and R2 cube is nothing but your D these values. Okay, by 2, so you can get the R1 value. Okay, and by 2 you can get the R2 value. Okay, 11 mm, and this will be so 38.5, around 39 minus 11 cube by 39 square minus 11 square. Okay, so we can get the value of T2. So we can get the total value of T1 plus T2. Okay, so just try to do that. So I have got an answer of 220.90 into 10 to the power of 3. Okay, so the T1 that I have got is 307.86. okay, 307.86 plus 220.90 into 10 to the power of 3. Okay, so we'll be getting an answer. So I have got an answer of 528.76. 528.76 into 10 to the power of 3. So we can get the length of the handle by if you substitute torque by force applied. Okay, so 528.76 into 10 to the power of 3 by the force applied 300, we can get the length of the handle. So I have got an answer 1762. Okay, so 1762 mm. So for gripping purpose I will be giving as some amount. So I have got an answer of 1800. Just for gripping purpose I have gave this amount. Okay, so so the length of the lever will be 1800 mm. Okay, so the next thing that we have to do is we have to calculate the M value. M is equal to force applied into length of the lever. So M can be calculated. So M is equal to force applied is 300 into 1800. Okay, so we can get the value of M. We will be getting almost the answer equal to here only. Okay, so 1800 into 300 got as 540 into 10 to the power of 3. Okay, so but actual will be actual bending moment formula is, so just we will be equating the bending moment with the bending strength formula, that is M is equal to pi by 32 into sigma b into d cube. Okay, so all the things that we are doing for the calculation of D3. So D3 is nothing but your diameter of the handle. Okay, so in order to calculate the diameter of handle, we are just equating the bending moment with the bending strength equation. So so here sigma b is nothing but your compressive strength of the material that is given. So the compressive strength of the material, that is 200 megapascals they are given. So by factor of safety we will be using as 100 megapascals into 100 into d cube. So M value is 540 into 10 to the power of 3. So we can get the value of D here. Okay, so I have got an answer of 38.03. Okay, so this is the value that I have got. We can close the problem here, or else we can continue with the design of the body. So the design of the body is some things we need to remember. So those things are not available in the data book. Just try to remember, or else you can neglect those values while designing. If he asked particularly to design of a body, means you need to remember something. So D5 is equal to, that is the diameter of the body at the top will be D5 is equal to 1.5 of D2. So the D2 value will be that we have calculated 79.74. okay, so and next we need to calculate thickness of the body. So the thickness of the body is T3 is equal to 0.25 into D naught. So 0.25 into, so the D naught value that we have taken from the tabular column, that is 44. This will be 79.74. Okay, and later we need to calculate the inside diameter at the bottom. So at the bottom of the body and outside diameter at the bottom. So that can be calculated by, so the inside diameter can be calculated, D6 is equal to 2.25 into D2. Okay, so same D2 value, and D7, that is 1.76 into D6. Okay, so the outside diameter of the bottom, inside diameter at the bottom. Okay, so thickness at the base circuit, T is equal to 2 into T1. So the T1 that we have calculated earlier, so see here, that is 10 mm. Okay, so the maximum height of the body is maximum lift plus height of the nut plus 100 mm extra. Okay, so that can be calculated. So these are the things that are used for design of the body that we can calculate in the design procedure, or else we can neglect that. Or if you want to calculate, means you need to remember all these values. Okay, so 1.5D, So everything you have to remember. So let me write those things one by one so that you can remember those things. Okay, so dia of the body at the top d5 is equal to 1.5 d2. okay, dia of the body at bottom. okay, so bottom వచ్చేసరికి d6 is equal to 2.25 into d2. okay, dia, this will be the inside dia and outside dia at the bottom, that is d7 is equal to 1.75 d6. okay, next thickness of the body at the top. okay, at the top t3 is equal to 0.25 into d0. so d0 will be that we taken from the tabular column. so d2 that we have calculated, d6 that is got it, and thickness of the body at the base. okay, so t4 is equal to, that is sorry, t2 is equal to 2 into t1. okay, so t1 is that we have calculated earlier, that is 10 mm. okay, t1 t వచ్చేసరికి ఏంటంటే that we have taken from the tabular column, t1 వచ్చేసరికి మనం క్యాలిక్యులేట్ చేసాం. ఓకేనా, నెక్స్ట్ వచ్చేసరికి height of the body. height of the body is nothing but height of body is nothing but lift, maximum lift that is given in the question, plus height of nut plus 100 mm extra that we have to take. okay, so this is the things. okay, with that we can find the height of the body. okay, so the height of the nut can be calculated by, so the height of the head, that is head can be calculated by 2 into d, capital D. so the capital D will be 42 or 44, sorry, that we have taken from the tabular column, 44.5, right? so height of the nut can be calculated. so lift వచ్చేసరికి h, that is given in the question 400 mm అని ఇచ్చారు, and height of the nut can be calculated by 2d. so d వచ్చేసరికి ఏంటంటే diameter of the handle that we calculated using bending moment formula యూస్ చేసి calculate చేసాం కదా, d మాట అండి. ఓకే, సో జస్ట్ యూజ్ దట్ వాల్యూ. ఓకే, sorry, here height of the nut వచ్చేసరికి ఏంటంటే కనుక that we have calculated by h by v formula just find out చేసాం కదా, so h అండి. so that's why we can directly insert that value. okay, సో h వాల్యూ డైరెక్ట్గా మనం ఇన్సర్ట్ చేసుకోవచ్చు ఇక్కడ, హైట్ ఆఫ్ ది నట్ అని చెప్పేసి. ఓకే, సో 2d అని చెప్పేసి కాదు, ఇది కాదు. ఓకే, డైరెక్ట్గా వాల్యూ ఇన్సర్ట్ చేసుకోండి, ప్లస్ 100 mm. సో యూ కెన్ గెట్ ద height of the nut here, so height of the body. so last thing that we can do is we have to calculate the efficiency of the chuck. so the efficiency is calculated by t0 by t. okay, so t0 by t calculate చేస్తే కనుక you can get the efficiency. one thing I have forgotten is to calculate the buckling strength. so buckling value వచ్చేసరికి l by d ratio యూస్ చేసి చేయండి. so length of the handle by diameter of the handle. so pitch diameter l by d, so l length by pitch diameter. so length of the handle by pitch diameter చేస్తే కనుక you can get the value of whether it is buckling or not. If the value is more than 7.5 means it has to be buckled. Okay, then you can apply the value concept of buckling. Okay, buckling concept apply chesi just try to do that. Okay, thank you all. So with this we have completed this formula. Just we will go for the next formula, next problem. So with this we have completed one problem. Okay, thank you all.